Howdy, today on Flippin Science we're going to be doing an example energy density question. So here's the question. Octane is one of many hydrocarbons found in petrol. Octane has a density of 0.8 kilograms per litre and an enthalpy of combustion of minus 5,512 kilojoules per mole. First part, write a thermochemical equation for the complete combustion. I'm going to highlight some important parts up here first before I start. So we've got the density, we know it's octane, and we know its enthalpy of combustion in kilojoules per mole. So that's the delta H value there. So I might put delta H next to it. So write a thermochemical equation for the complete combustion. First thing we need to do is figure out what the formula of octane is. So I'm going to draw a little octane over here so I can do it. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have hydrogens all over the place. The reason why I'm doing this is so to make sure that I get the right number of hydrogens. You can use a formula if you can remember the formula. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18. So C8H18. So I'm going to write that down over here. So C8H18. Now octane, it's a liquid. It's in petrol. Plus some oxygen gas. And goes to some carbon dioxide, which is a gas, and some water, which is a liquid, and my delta H value is minus 5,512 kilojoules per mole. Let's just get rid of this now. Now I need to balance the equation, so I've got 8 carbons over here, which means I need 8 carbon dioxides. Got 18 hydrogens, that means I'm going to need 9 waters, so 9 times 2 is 18. Add up my oxygens, so I've got 8 times 2, so that's 16 plus 9 is 25, so it's going to be 25 on 2 oxygens. So there's my complete thermochemical equation. Next bit, calculate the amount of energy released when 1 gram of octane is completely combusted. First thing we need to do is figure out how many moles are in 1 gram of octane. So, and octane, mass on molar mass. So the mass is 1 gram. The molar mass is going to be 8 times 12.01 plus 18 times 1.008. I'm going to put that into my calculator. 1 divided by, put it all in brackets, 8 times 12.01 plus 18 times 1.08. I get 8.75 times 10 to the minus 3. So I'll put that down here. 8.75 times 10 to the minus 3 moles. Alright. So now that I have that number of moles, what I'm going to do is I'm going to multiply that by the number of kilojoules per mole, and that will tell me how many kilojoules I'll get from 1 gram. So I'm going to call that a delta E value now. So delta E equals 55 times by 8.75 times 10 to the minus 3. That should give us a fairly small number. So I'll go back to my calculator. So times the answer by 5512. And I get 48.25. So 48.25, and that's going to be kilojoules, because we're still in kilojoules from our unit up here for enthalpy. So that's the number of kilojoules released when 1 gram of octane is burnt. Next part of the question says 200 mils of octane is used to heat 3 litres of water that has an initial temperature of 21 degrees. So I'm going to highlight some important stuff there. So I've got 200 mils here, it's 3 litres of water, and the initial temperature is 21 degrees. First question is, what is the mass of 200 mils of octane? So that's when we're going to look back at our density. So if we look at our density here, we've got 0.8 kilograms per litre. So I'm just going to write that down over here. So density is 0.8 kilograms per litre, which means that in 1 litre you're going to have 800 grams of octane per litre. 200 mils is 0.2 of a litre, so if we times that by 0.2, we'll get our answer. Now, you shouldn't need to use a calculator for this, but I'm going to anyway, just to show you how to do it. So, all clear, so 800 times by 0.2, and that's going to be 160. So we get, so that's going to be 160 grams of octane. So 160 grams of octane. Right, then it asks how many moles is this? So I'm going to do N equals mass over molar mass. So I'm going to do what I had before. So this time it's going to be 160. We're going to be, so it's 12.01 times by 8 plus 18 times 1.008. I'm going to go back to my calculator. So 160 divided by, so it's 12.01 times by 8 plus 18 times 1.008. And I get, so that's 1.4 moles. Go over here. So I get 1.4 moles of octane. So that's how many moles it is. Next step, it asks how many joules of energy. Now I'm going to highlight joules because our kilojoules per mole before, our enthalpy is in kilojoules per mole, so I'm going to have to worry about the 1,000 there. How many joules of energy can be produced by this amount of octane by combustion? Alright, so what I'm going to do is, I'm going to write down my delta H value. So in this case, because we're looking at the amount of energy that's going to be produced, I'm going to call it a delta E value. So that's going to be equal to my delta H times by my number of moles. And then we're going to multiply that by 1,000 to get us back into the unit of joules from kilojoules. So it's 1,000 joules in a kilojoule. So that was 5,512 times by our number of moles, which was 1.4, and then times that by 1,000. So I'll shove that into my calculator. So 1.4 times by 5512 and times by 1,000. I get 7720969. So we've got 7.7 times by 10. Now let's have a look at how many decimal places we need to go to here. So 1, 2, 3, 4, 5, 6. So 7.7 times 10 to the 6 times 10 to the 6 joules. So we get 7.7 times 10 to the 6 joules of energy, and that's the amount of energy that's being produced by burning that amount of octane. Then it says, if all this energy heats the water, what will be the maximum of the water? So that means maximum temperature of the water. So now we need to worry about our delta T formula. So we're going to do a change in temperature. Because we're just using delta E, we can use delta E, so delta E equals Cp times delta T times by the mass of water. So delta T is going to be equal to, so up there these are times up here, so multiplied up here I should say. So we've got delta E, that's going to be divided by the specific heat times by the mass of water. So our delta E, that's this number up here, so 7 times 7 times 10 to the 6 joules of energy. Our specific heat of water is 4.18. And the last bit is the mass of water. We need to figure out how much water we're heating up, and I think it's 3 litres. So we're heating 3 litres. 3 litres of water is going to weigh 3,000 grams, and our unit here is in grams, so we need to use that. So I'll grab my calculator. So we've got our answer there, and we're dividing that by 4.18 and times that by 3,000. Alright. And we get 615.7. So the temperature of the water that the water will end up will be 615 degrees Celsius. So we'll add that to the 21 degrees that we started with, and we get 636 degrees Celsius. So that's an example energy density question. That's it for Flipping Science today. See ya.